Hey everyone, in this video we're going to talk about systems of linear equations. Now this topic is one that I think intimidates a lot of people, but I don't think it needs to. I think it's a simpler topic than most people oftentimes think it is. Um, but uh, but yeah, hopefully after this video this will make a little bit more sense and it'll be a little less intimidating if this is a topic that's intimidating to you. So I want to show a few different methods for solving systems of linear equations. Before we do that, I want to briefly explain the idea of what we're trying to do here when we solve a system of linear equations. Okay. So when you see a system of linear equations, in all of the examples, we're going to have two. Here, we're going to have two equations in our system, and what we're trying to do here is we're trying to figure out where the like if you think about this like a graph, you might have two equations of lines, and they are going in different directions. I mean, this is line one, and this is line two, and here you're trying to figure out exactly where these two lines intersect each other. Okay, so these two lines you could represent as a system of linear equations, kind of like we see here in these two examples, and the goal here is to figure out where they intersect. So we're going to see if we can try and do that without graphing these equations, at least not now, okay? We're going to try to use this doing just basic algebra techniques. All right, so let's get rid of this and we can get started. The first technique I want to look at is called substitution, okay? And this is one that will usually work. This is one that really, I think, in all cases, if they're a consistent system, it should work, at least with a two by two system. It should work in just about any situation. But a lot of times it can be messy. So we have a few techniques we're going to get to later. But sometimes you're given a situation where things will work out quite nicely. So if you're given a situation where you can use substitution, what you're going to do is you're going to first solve for one variable. So in this very first example, we're given a very easy situation where it's already solved for one of the variables. Here, it is solved for y. So we have y is equal to 2x plus 1. All right? So what we can do is, since we know y is equal to 2x plus 1, we can take this y here and plug it in right here in for this y. Okay? And what that's going to do is that's going to make this first equation an equation that is based just on x and not on y as well. So this new equation will become 3x plus 4 times 2x plus 1. And we got that 2x plus 1 because we said y is equal to 2x plus 1 here. And this is equal to 26. Okay, so now what we can do is we can solve this equation for x, and we should be able to just reduce this to a number. All right, so let's go ahead and distribute this 4 here. So we'll have, this will become 3x plus 4 times 2x, so plus 8x plus 4 is equal to 26. Okay, we can combine our like terms, and we'll have 11x plus 4 is equal to 26. You take 4 away from both sides, and we'll get that 11x is equal to 22. If we divide both sides by 11, scoot this down here. If we divide both sides by 11, we're going to end up with x is equal to 2. Okay, so now that we know x is equal to 2, we can go ahead and plug this x value into either equation here, and we can solve for y. I think it would make the most sense to use the one that's already solved for y. So let's go ahead and do that. So now we can take this x and plug it in here. So we'll have y is equal to 2 times 2 plus 1, or 4 plus 1, which is equal to 5. So here we have x equals 2 and y equals 5. There we go. There is the solution to this system of linear equations. All right, so let's take a look at this example. Here we have negative 2x plus y equals 7 and 3x plus 2y is equal to 7. Okay, so let's go ahead and try and solve this via substitution. So the first thing we ought to do is isolate one of our variables. And we can really do this, you can pick any variable in any equation here to try and isolate. But I see one in the first equation that seems to make the most sense. So here we have negative 2x plus y equals 7. If we just add 2x to both sides of this equation, we're going to have y is equal to 2x plus 7. So if we just rearrange this top equation here by adding 2x to both sides, we'll get y equals 2x plus 7. Okay? And now what we can do is we can go ahead and substitute this y equals 2x plus 7 into this equation here. So this will become 3x plus 2 times 2x plus 7 is equal to 7. So let's distribute this 2, and we'll get 3x plus 4x plus 14 is equal to 7. All right, so if we combine like terms, we'll have 7x plus 14 equals 7. Now we can take 14 away from both sides, and we'll get 7x is equal to negative 7. And if we divide both sides by 7, we'll end up with x equals negative 1. Cool. So now we can take this x equals negative 1, and we can plug it in anywhere here. But I'm thinking we take it into this equation right here, okay? Keeping in mind that this is the same equation as this equation, so we can go ahead and do that since we've already solved for y. All right, so we have y is equal to 2 times negative 1 plus 7, or y equals negative 2 plus 7, which is 5. So x equals negative 1 and x equals 5 is our solution. Okay, another method that we have that we can use is addition or subtraction. Okay, we can use addition or subtraction to solve these. Since these equations are connected, we can add or subtract these two equations from each other. So let's go ahead and see what happens here if we were to add these two equations together. So what this means is we'll add the x's to the x's, we'll add the y's to the y's, and the constant values to each other. So here we have x plus negative x, so we get 0. Then we have 4y minus 6y, or plus a negative 6y will give us minus 2y. And then we have 17 plus a negative 23, which will give us negative 6. Okay? And so what we end up with, what we notice here is these x's went away. This x and the negative x went away. And that's because we had an x and a negative x, and you add them together, you get nothing. So now we have another equation that we got from the previous two equations, which really just involves y. And so here what we can do is since we now have negative 2y equals negative 6, we can divide both sides by negative 2, and we'll end up with y is equal to 3, since negative 6 by negative 2 is 3. Okay, and now we have, since y equals 3, we can plug this y value into our favorite of our two equations up here. All right, so let's go. I guess my favorite would be the top one, I guess. So let's go ahead and do that. So we have x plus 4 times 3 is equal to 17. Or we have x plus 12 is equal to 17. And if we take 12 away from both sides, we get x is equal to 5. So here we have x equals 5 and y equals 3 as the solution to this system of linear equations. Okay? But what if we want to subtract this equation from another equation? Let's say we want to see an example where we maybe want to subtract instead of add. So in this one we have negative 3x plus y equals 8, and here we have 7x plus y equals negative 12. All right, well let's see what happens when we want to subtract. Here, we know we have a positive y and a positive y, so subtraction seems to make sense here to eliminate that y variable, and really we'll just have the x's left over. So let's go ahead and subtract. So now keep in mind we have to subtract each individual instance here, so we can actually rewrite this as adding a negative version of this bottom equation. So really this will be 3x plus y equals 8, and we're going to add negative 7x minus y is equal to positive 12. So we'll just make everything that's negative positive and everything that's positive negative here. Okay, so negative 3x plus a negative 7x, that'll be negative 10x. Y plus negative y is 0. And then we have 8 plus 12 is 20. So now we can divide both sides by negative 10. And we get x is equal to negative 2, since 20 divided by negative 10 is negative 2. And now we can take this x equals negative 2 and plug it into our favorite equation up here. I think in this situation, again, I like the top equation best, so we'll do that. So we have negative 3 times negative 2 plus y equals 8. Or we have 6 plus y equals 8. We can take 6 away from both sides, and we get y equals 2. So if x equals negative 2, y equals positive 2. Okay, so what about a situation where you want to solve it, but there doesn't appear to be an immediate way to add or subtract, and you have a suspicion that maybe substitution would look a little bit messy, and it would probably involve a lot of fractions. Keeping in mind, if you ever get stuck and you're not really sure what to do, substitution is almost always an option. Okay, so you can use substitution when in doubt. Okay, it might look really messy, but it will get you where you're trying to go. So if you're on the final and you see a system of linear equations, you need to solve it, and you don't see a very obvious way to solve it, unless it tells you explicitly that you can't use substitution, then that should always be an option available to you. Okay, so if you ever get stuck and you need to use substitution, that's a good way to go. But there's another trick here as well that we can use, and that is very similar to the previous example. It's just taking advantage of the fact that we can, since we have equality here, we can multiply both sides of an equation by something without really changing the overall value of the equation. Okay, so what we can do is we're allowed to multiply one or both of the equations in our 2x2 system here by numbers individually, and then add or subtract them from each other. Okay, so let's just kind of work through this example, and maybe you can see what I'm talking about here. So here we have negative 9x plus 4y is equal to 23, and then we have 3x plus 2y is equal to 19. So if we were to go ahead and multiply the bottom equation here by 3, what we'll have is a new system here. We'll have negative 9x plus 4y equals 23. And then we'll have, so once we distribute this 3 to everything in the equation here, we'll have 9x plus 6y is equal to 19 times 3, which is 57. And now what we can do is, since we have this new system here, and we didn't really change the overall value of anything because all we did, we multiplied both sides by 3, now we can go ahead and add these two together. So we can add negative 9x plus 9x. That'll give us 0. And then we have 4y plus 6y. So we have plus 10y. And then we have 23 plus 57, and that's going to give us 80. So now we can divide both sides by 10, and we'll get y is equal to 8. Okay, so now we can take this and we can plug it into our favorite of our two equations here. And I'm thinking the second one looks probably a little easier. So we'll have 3x plus 2 times 8 is equal to 19. Or we have 3x plus 16 is equal to 19. If we take 16 away from both sides, we'll end up with 3x is equal to 3. Dividing both sides by 3, we get x is equal to 1. So x equals 1 and y equals 8 is the solution here. And it's important to know as well that we could have plugged this y equals 8 into either of these. I know I said this a couple of times, but let's see what happens if maybe you would have chosen the other one. You should get back the same result. So if we have negative 9x plus 4 times 8 equals 23, we'll have negative 9x plus 32 equals 23. So we can take 32 away from both sides, and we'll have negative 9x equals negative 9. Dividing both sides by negative 9, we get x is equal to positive 1. So, like I said, you really can choose whichever of the two equations you like better. You should get the same result back in either case. Okay, so let's look at one more example here where we have to do multiplication as well as addition and subtraction. So in this example, we're probably going to want to multiply both equations by something. Let's work through why that is. So here at the top one, we have negative 9x minus 4y is equal to 24. And then we have on the bottom, we have 7x plus 3y equals negative 19. Okay, so I'm not seeing an immediate candidate here for eliminating one of our variables, but I am seeing one where if we're able to multiply both of these by something, we might be able to eliminate the y variables quite easily. We can also do this with the x's as well, but I'm going to choose the y's here. Okay. So what we can do is we can multiply this top equation by 3, and we can multiply this bottom equation by 4. Okay? And that will give us negative 27x minus 12y is equal to 24 times 3, which is 72. And on the bottom, we have 7x times 4. That's going to give us 28x. And we have plus 12y. And we have negative 19 times 4, which is going to give us negative 76. So now we have this new system of linear equations over here, and we can actually add them, and we should be able to get rid of this y variable here. So if we have negative 27x plus 28x, we get just x. So we have negative 12y plus 12y gives us 0. And then we have 72 plus a negative 76. That's going to give us negative 4. Okay? So we have x equals negative 4. Not too bad, right? So now what we can do is we can take this and plug it into our favorite equation. I guess I'll go with the second equation here. We can take it up here. It's also worthy of note, you could also plug it into either of these two equations as well. And that's because we haven't changed any of the overall value of them. Although I would probably recommend against doing these because the numbers get a little bigger and therefore multiplication might get a little more hairy, but it is a valid choice. Okay, so let's go ahead and see what happens here. So we have 7 times negative 4 plus 3y equals negative 19. 7 times negative 4 gives us negative 28 plus 3y equals negative 19. All right, so then we can add 28 to both sides. and we'll get 3y is equal to positive 9. So now we divide both sides by 3, and we get y equals 3. So x equals -4 and y equals 3 is the solution. So there we go. This has been a brief introduction to how you can solve systems of linear equations. Most of the examples that you're going to see, at least in the first few topics, involving systems of linear equations are going to look a little bit like this. I will say sometimes you might want to multiply by a fraction. Maybe sometimes you want to multiply both. Maybe sometimes you want to multiply just one. Maybe you don't have to use this technique at all. Maybe you can use addition or you can use substitution. But there are lots of methods available to you for solving systems of linear equations. So yeah, if you have any questions at all, please email me and I'd be happy to make a video with more examples if you guys want to see that. So yeah, have a good one.